is preparing. I'm just gonna quickly hop on to sweet. All right, I see us. Direct link. Data science Q&A direct link. Sweet. Everyone's been informed. Hopefully I didn't dox anybody. Sweet. Okay, cool. I am going to turn off my internet here so that I have my questions. So we should be good. And for people who are tuning in, let's see. Okay, we have 2 watching right now. Why don't we wait until we have a few more people? We have about 30 seconds, but yeah, for the people who are in now, if you could just pop a question into the chat, or just a comment or anything into the chat, just so that I can know that it is working, that would be a very appreciated thing. Okay, got it. Live stream is going. Now I'm just adjusting my browser so that I can see Mallory and the questions as they come in. Okay, so we've got 4 people. If any of the 4 people who are currently watching could pop a question or 2, or just anything into the chat just to say hello, so that I know that that's working. There's about a 30-second delay, so I won't expect to hear anything from people for about 30 seconds. But yeah, if someone could just start popping questions into the chat, those I can see immediately. Cool. All right. Have 5 people. We have about 30 or so signed up. So let me very quickly. And if someone can also tell me if the audio sounds scratchy or weird or anything, that would be appreciated. Cool. Yep. You just sweet. Yep. You asked a question, so your question will be there. Aisha, you asked a question as well. So actually you're on top of the list. So stay put. Cool. Have about 6 people in right now. Let's wait maybe another. Oh, Reza Lion. Oh wow, all the people who ask questions are also very conveniently being nice and popping something into the chat. So I appreciate that, guys. Also, don't forget while you're there, if you pop the like button early, it'll make sure that people, YouTube will show it to people who are just like sort of like milling around on the internet right now. We might catch a few stragglers, but yeah, cool. Got 9 people. We have about 40 signed up. I would guess that probably I'm happy to start when we have probably about 15 or 16 people, and I'm just gonna very quickly check that I'm not getting angry emails from anybody, and that they're happy with the link. But yeah, cool. Audio is fine. Sweet. Thanks for that. Yeah, I was checking I was trying to do basically. I had 3 computers open when I was trying to do it myself and check the live stream stuff, and it sounded horrible. And I couldn't figure out where the feedback was coming from. But I do appreciate that. But yeah, Resaline, if you could just sort of be our like our master of audio, and if anything gets like weird audio wise, just let me know. I'd appreciate that. Cool. We got 10, 5 more, and we will get going. Yeah. So just so you know, Aisha's question will be first. Reza Lion's question will be second. Oh, and then there's another Aisha question. I'll just answer Aisha's questions together. And then Reza Lion, you posted 2 questions very kindly. And then Yuja Chen will get to your question, and then we have plenty of other people. Cool, got 11 people, sweet, and 3 likes. So far, so good. Don't worry, if more people aren't here in about a minute, I won't waste any of your time, more of your time, and we'll just get going on the Q&A because the people who asked the questions are here. Sweet. I guess that'll also have time for me to ponder an introduction for Mallory. I'll cut all this like rambling bit out at the beginning once YouTube lets me. But Mallory, it's always great to see you again. You're pretty much one of the easiest guests who I've ever invited onto the show. With just people who just like, yeah, let's just get stuff done, and not making me write like paragraphs out. Actually, Mallory, if you could say something just so we can hear your audio and do final audio check, that'd be good.
Yeah. Hi, everyone. I hope I sound all right. Thanks for having me again, Glenn. I'm really excited for this Q&A.
Yeah, sweet. And also, you've had some changes. Where can we submit questions? If you submit them into the right where you're asking that question, Yair Montefar, if right where you're submitting that question, just submit another question related to data science and we'll answer it. There's about a 30-second delay between us speaking and what you'll see on the live stream. But other than that, yeah. So yeah, just submit your questions there. We will go through the questions that were submitted in advance first, and then we will get to the live questions. And also, if you can hear me slurping too much, let me know. That would be appreciated too, because I don't want to be discussing on live. Okay, cool. We have 12 people. I think that's enough to get started. I respect your guys' time. Haven't yet, don't forget to smash that like button. It is the way that you actually tell the YouTube algorithm that you like it. So please do that. But yeah, Mallory, welcome to the show. You've just, I believe, finished your first summer term, the crash course, the boot camp of the Masters in Analytics at NC State's University, the Institute of Advanced Analytics, which is very cool. I respect that program. I think it's probably, I haven't heard of a better program with regard to meeting the needs of master's degree students, particularly early career people or alternatively mid-career people who are looking to essentially boost their, for example, managerial capacity or their current professional abilities with analytical data science type skill sets. So I really respect your program. I like the people who are running it. And I wouldn't just say that for any random program. If one of their grads got on, I'd just probably avoid the topic if I didn't respect the program. But I do respect yours. I think it really does meet the needs of its students. And I think that's something that you can't just take that for granted. But yeah, Mallory, maybe if you could just give us a quick 15 to 20-second rundown on what your experiences has been so far since you entered NC State several years ago.
Yeah. So hi, everyone. My name is Mallory LaRusso. And as Glenn said, I have just started my master's in analytics at the Institute for Advanced Analytics. I started my undergraduate career back in 2018 at NC State University as well, majoring in statistics and getting a minor in genetics. And throughout my undergrad career, I did some undergraduate research, and I also had an internship at SAS. So I'm excited to answer any questions about any of my undergraduate experience and my limited graduate school experience so far.
Cool. Yep. Perfect. And what we're going to do format wise is I have the questions here. Just so you guys know, Mallory is right here in my view. You guys are right here. And then the questions are right here. And what we'll probably do is I'll read off the questions, and then Mallory and I will trade off who answers first, unless there is some more immediate priority that comes to mind. But the first question is Aisha's question. What are some analytical or statistical techniques that you find yourself using the most? So maybe I will just go first on that. So day to day, I try to use I try to use sort of bread and butter statistical and data science techniques more than I'll use sophisticated ones. And so just for those who don't know, my PhD at Oxford University was on Bayesian nonparametric time series modeling. So essentially I was trying to figure out how to automate the statistical inference. So not only model selection, but the actual inference algorithm, and then the clinical decisions that come from a fitted time series model for patients. And the challenges were, how do I get that fit in real time without human tinkering? So for example, for statisticians, a lot of times in research, we can actually hand tune a model, or we can look at the result and decide whether or not it's a good fit or not. In cases where it's patient monitoring, these are live. You don't get to watch the model because obviously there's one being fit, every minute or so and across hundreds of patients. So you don't have the benefit of getting to hand tune your model and recheck it. So a large part of my work was not just on model selection and inference, but also on automating that process so it can work without an actual researcher looking at it. Despite that, though, day to day, I prefer to use more bread and butter. Bread and butter for me means basically anything that was created before the 1970s. I can really get along most of my day using fairly, I would say, sophisticated but basic techniques. So as in they're very common, but they have a certain aspect of sophistication that's not very, they're sophisticated in their capability without actually being, for example, mathematically complex or having the inference being complex. And I think that's an important distinction to make. But yes, I use a massive amount of visualization, always start things with visualization. I then typically do some dashboarding to get feedback because I report to software engineers and other people in the business unit. So essentially I visualize it for myself, decide some important hypotheses, then allow the other people I work with to generate their own hypotheses and get feedback. And then for the algorithms that I use, for example, with anomaly detection, I usually try the simplest methods that are possible before making it difficult. And one thing that I've noticed is that actually it's sort of like an accordion effect where you might start with something simple, and then as you want to incorporate more dynamics, you might make your model more complex. So like an IID model versus a time series model. It's sort of strange. Did my doctorate in time series, but if I can squish anything into an IID model first, I'll definitely do that. However, as the model gets more complex, sometimes what you realize is that, oh, I can actually simplify this because you might actually be prioritizing simpler dynamics. So that's when the accordion starts coming back in, and you can actually take a complex model, you realize what that model is really flagging or bringing to light, and then you realize, oh wait, I can actually use a simpler algorithm to do that. So specifics, I'm a big fan of, for example, kernel density estimation, basically just pop down density where you see data. That's a big one. A lot of very basic, for example, univariate and simple multivariate distributional fitting. If you can get good at that and maybe add a little bit like Bayesian flair to help with your regularization process, you can actually get pretty far using simple tools. And that also makes sure that the more complex tools that you use will be on a good foundation. So yes, I always go visualization and simple models first. I tend to stay in the probabilistic side of things. And I think that's, yeah. And Aisha, you are you're the person of the hour. So to whatever extent we haven't answered, whoever's question we're asking, feel free to pop a question or follow-up questions in the chat and we'll answer those directly. But yeah, Mallory, what about you? Because obviously you had an internship at SAS on genomics.
Mhm.
What did you find yourself using there, and sort of what do you see yourself using in the future? So if you could two-part that question, I'd appreciate it.
Yeah, of course. So kind of on the genomic side of things, I used a lot of Python for my analysis. We use this thing called BLAST, which is a part of the BioPython package. So I use the output from that, and then I would visualize it using SAS Visual Analytics. I would highly recommend learning either Tableau or SAS Visual Analytics. Those are some great dashboarding tools that you can use, and you can really communicate some complex ideas in simpler terms for your audience. And then I think outside of the genomics world, I kind of go along with Glenn. I always start with exploring the data, doing simple bar charts and box plots, the things that you learn on day one. Those are really important to get to know your data. And you can run a lot of times from those visualizations, you'll see associations or interesting trends that you want to back up with statistics, because a key thing, like you can't infer anything from a graph. You can say, oh, it looks like there's a trend, but running those statistical tests will really kind of put the proof to back up what you're seeing in a graph. And then from there, we go into model selection. And then I find that multiple linear regression and logistic regression have been the kind of two models that I've been using the most so far. I didn't do very much modeling when I did genomics. It was more on just the identifying mutations and visualizing them.
Yeah, that's really good. And just to sort of riff off some of Mallory's ideas, you mentioned, for example, using Tableau or a SAS visualization project. And so some of you might be thinking, it's like, well, I already know Python. Python has a variety of really nicely designed internal packages. For example, matplotlib, Seaborn, Plotly, or the Dash, which is, I believe, the enterprise version of it. And you might find yourself wondering, it's like, well, why would I be using some of these more expensive enterprise solutions when they are available in, or when they're essentially already available in my Python notebook, and I can just use that. And some very quick, many of these are actually very practical, sort of organizational issues, where effectively, while you have access to your Python notebook, your coworkers don't, and you might be working with less technical people in a business unit, and they're used to essentially having Tableau or some of these, I guess, Power BI or some of those visualization things. Archaeopteryx, I guess, is another one, fed to them in some way. So effectively, one of the reasons that you might be expected to do this, it's not a silly thing, is that the rest of your business unit might be better set up to be using those resources. So essentially feeding them in, piping them in, and having those initial views is something that is of organizational value, regardless of what you personally can do via Python. Cool. And Microsoft Power BI. Yep. Cool. Yep. Said one of the things is SAS Visual Analytics and Tableau is good. Microsoft Power BI is also good, but Tableau is the most common. Yes, I would agree with that comment. And so one of the main reasons why we have these, despite having our own thing in our data science world, is that there are organizational issues that these things facilitate. A lot of enterprise solutions, well, if you're working within an enterprise, you're gonna have to work amongst all those other people, and they sort of roll that out for you. Cool. So if people are satisfied with that one, I will move to Aisha's next question. How do you stay up to date on the world of analytics, hot topics in analytics, etc.? Maybe I'll just kick that one off too, since essentially Aisha asked, it's still her question. And there's several ways that I do this. One, I read quite a bit. And so, let me put it this way first. Staying up to date is not the same thing as learning. And staying up to date and learning is not the same thing as, learning is not the same thing as learning what is newest. So there's one thing where it's like hot topics, and there's another bit where you're just generally continuing to learn. And I think that one mistake that a lot of people early on make is that they think that in order to stay up or in order to continue learning, it means that they are, staying on the cutting edge. Staying on the cutting edge is, of course, very useful. But at the same time, you can also learn a huge amount by learning all the other older things that you had sort of passed by on your first pass through. And so it could be something as simple as like learning a model that's new for you, but essentially old for the rest of the community. If you don't know those things, if you don't know the basics, then going back and reviewing some of these things is extremely helpful. And I think that one of the things that people really can use a second pass on is getting a better idea about the inference algorithms, for example, that they're using to fit their models. And so, for example, say that you're really good with linear regression and logistic regression, which, Mallory, you said you've found success in using those, and you're really good at those. And you say, well, I can do one of two things. One, I can try and stay up to date on neural nets, or alternatively, I can figure out how to do alternative forms of inference using linear regression. So, for example, perhaps I'd like to do Bayesian inference or have a Bayesian linear regression model. And once I have a Bayesian linear regression model, it's like, well, do I want to use my MAP, which is maximum a posteriori estimate, or do I want to integrate over the parameter space and things like that? And there's a number of areas where effectively you aren't learning new models. You're learning new inference techniques, and people are developing those new inference techniques as well. So that's just a broad thing that I know that's not quite the question that you asked, but is a sort of a category. I'd strongly suggest that you don't think about it just staying on top of whatever's coming out of, Zubin Girmani or Jan LeCun or Jeff Hinton's group. It's also continuing to learn the basics that you sort of passed through and missed the first time. And I think that's a lot more important, actually. because the more solid you are on the basics, the more you can innovate. With keeping up on the more advanced things, I think that, for example, if you go to NeurIPS, you don't have to go to NeurIPS, just go to their website, read those types of things. They're really well written papers. A lot of research groups actually now have put a lot of work into keeping up, making sure that their websites are very accessible. So, for example, if you go to David Duvernod's website, I think he's at University of Toronto right now. He's definitely up in Canada, but you can go to these people's websites or the Zoom Germani website, and you can look at these different research groups and just see what they're up to. And they'll have high level descriptions, and that will allow you sort of to be like you're going through a grocery store with a shopping cart and saying, yeah, I'd be interested in learning that. That's not so interesting. I'd be interested in learning this. And you can just sort of get a high level view from people who are good at communicating. So I hope that lays the stage. That was a long answer. Mallory, what's your answer?
Yeah, so I can go in a kind of different direction than you did, because I think reading up on the most important and the newest analytical things is very important. I know that in terms of the Institute for Advanced Analytics, we have a blog that we put out every so often. And so it's just kind of following current students, alumni, and their path and what they do. So that's a great resource to kind of hear from people who are doing what you want to do and the new things that are coming out. I also think that if you want, it's very important to do a project that you're passionate about by yourself. And I think a lot of learning and growing about analytics comes from that. Like, I remember in our practicum group, we were trying to see if two variables were correlated, and we hadn't learned a test for it. So we went down this huge rabbit hole trying to find all these different tests that we can do. We ended up finding like a biserial correlation test, which I've never learned before. And it was just like this whole world of analytics was open to me once I tried to apply it. And I was kind of driven to learn it because I was trying to solve this problem. So if you just kind of dig into data, you will find problems that you don't know how to encounter. And then you'll go online and you'll try to find solutions, and you can see what people are doing to stay up to date to answer those kinds of questions too. That's just kind of like a hands-on way to see the newest techniques to do things.
Yeah, I like that answer a lot, because essentially what Mallory addressed is not just learning new things, but how you direct your search. So your search path is what's important, and generally you're going to be searching down the right areas if it's applied to the problem that you're trying to resolve. So if you're working hard and really digging into your problem, there are aspects that are going to pop up that you're uncertain about, and that you should use that to sort of direct what you're doing, as opposed to saying, okay, I'm working in this one area, but instead of learning about what I need to apply it more to this area, I'm just going to totally jump fields and say whatever's fanciest and people are talking about towards data science or whatever. I definitely like that approach, and I'll admit that's the one that I follow. It might make you a little bit myopic at sometimes, but the fact is, the more deeply you learn something, the more rapidly you can get breadth in other fields. So I think that basically one important thing about learning is, if you learn one topic deeply, especially in data science, statistics, all of these analytical fields, you'll be able to more rapidly appreciate and learn other things. So it's definitely do a depth first search on your learning. But I definitely think that Mallory has that right as far as how to direct your learning process. Cool. Our next question is for Reza Lyon. What are some skills that you believe are the most essential to entry-level data science roles? So Mallory, what do you arm yourself with?
Yeah, so I haven't worked a data science role yet, but through this program, I have a good idea of what employers are looking for. So I think one of the most important things that's easily overlooked is being able to communicate with your audience and really understanding your audience. It's super important to know what your customers or what your teammates want from a presentation, and to know what their baseline knowledge is. Because if you go into a presentation and say something that's completely over their heads or something that they don't understand, it's not going to be worth their time. So really understanding the problem and understanding the important things to communicate are going to be vital. You need to ask those important questions early on before you start doing a lot of work. And I know teamwork is going to be a very important aspect as well. You are going to need help on an entry-level role. You'll need to be able to ask help respectfully and work with your teammates. a lot of the soft skills that you don't learn in school are the ones that are going to trip you up. So I think getting a good analytical background, learning programming, learning statistics, like you're going to be fine on that end. It's just the soft skills, kind of switching from being in a school environment to being in a work environment, that'll be the trickiest. I know I really struggled in my internship with not having like deadlines really. Like I was used to school being like, oh, we had homework due every Monday. These are the instructions kind of laid out for you. Then when I got into the real world, like they were like, oh, you have 3 or 4 weeks to do this. And like there wasn't strict intermediary deadlines and stuff like that. So it's just kind of rewiring your brain in that way as well.
Yeah, I like that. And I would though push back that on the idea that you haven't had any entry level experience, because you were an intern, and I would view that that's the entry level. And for people who struggle to get internships, they would definitely consider that to be a nice entry. So I guess just with that in mind, what skills did you think were useful, for example, to attract someone to let you like essentially have an internship? Were there particular things that you did, or communication skills or anything like that, even just how you got in contact with them in the first place?
Yeah. So I think one of the main reasons I actually got my internship was because of my job that I had on campus. I was a manager of a small team of people that worked at the gym. So I had experience presenting in front of groups and kind of leading a team. And a lot of my interview questions were centered around that. So I think it's super important when you're applying for jobs to do something outside of your comfort zone, even if it's something not related to your field at all. Like I was managing people at a gym, but I want to be a data scientist. So it was just that experience that gave me the soft skills to succeed and kind of set me out from other people. Did that answer your question?
Yeah, definitely. And I would say that you do exceed, you excel at many of those soft skills, because, for example, I found it very nice just working with you. Even like it's just, you make it super easy. And I'm not going to expand on that, but I will underscore some of the important things that Mallory discussed. So, for example, thinking about when you're presenting to somebody, especially who's non-technical, I know it's very when you're very early in your career, the simple fact is you know very little. Like you know very little analytically. You're not particularly skilled. However, you're vastly more skilled than anyone who's not analytical or anyone who's non-technical. And so while it might be gratifying to you essentially go from your like bottom of the totem pole on the technical spectrum, but you're like top of the totem pole amongst the non-technical people, it might be very gratifying to be like, oh, I'm going to play this up. I'm going to make it sound as smart as possible. That's the absolutely wrong thing to do. Even amongst technical people, they won't like it. And what I think is very helpful is like at all steps, put yourself in that person's shoes and assume like they have literally not thought about. So for example, you're going to talk about a project that you're doing. You don't just jump into it. Remember that they literally have not thought about this until the second that you started talking. And they're probably going to take a few seconds to even warm up to the idea. So always present yourself as if the other person is totally cold on the topic. And if that means that you spend more time introducing the idea and the motivations and things like that, you might not even get around to the technical bits. That's fine. They're not going to care whether or not you did, how you penalize your logistic regression cost function. They aren't going to care about these things. They don't even know how to appreciate them. But if you think about what they do appreciate, this is very helpful. And just so you know that I'm not just saying this, one of the best ways that I've distinguished myself is by basically always putting myself into the audience's shoes. And one of my first big successes was at EMBC 2016, I think, just to show like how old I am. But yeah, basically it was like a 1 minute lightning round question. Like you could present, because I was so far down on the totem pole, they basically just lined us all up and said, you have 1 minute to present and then you just get out of here. And so it was right before a poster session. And what I did was, I practiced the hell out of that 1 minute. And like I had 4 animations all in one slide. They gave us one slide in 1 minute. And I just like practiced the hell out of it. So it was like 30 seconds, 30 seconds, 30 seconds, 30 seconds on each of those quarters, and a little animation showing us exactly the next thing that they needed, like introducing the patient monitoring, introducing how I would flag it, introducing sort of the fun bit where it's like how I can make it a bit more sophisticated, and then the plot at the end showing that it worked. And I even had it down where the timing of when the videos would start running, I got that bit down. And the point was, and there's other people who didn't. And I'll tell you what, out of a crowd of about 30 or 40 people who were in that small room before we headed down to the poster session, I probably grabbed about 15 of them on the way down, and they followed me out and they kept talking about it because they appreciated and cared. If no one cares, it's not gonna be helpful. And I think that's also especially important because like it's JSM week. JSM is where the worst statistical presentations on earth congregate. And there's a few good ones, but like there's so many bad ones, and like no one cares, and no one wants to talk about this except I will, because I'm not in academia and I can just make enemies. But the idea is these things are very important, and you can really set yourself apart by putting yourself in those person's shoes. So I know I've gone on for this probably a little bit too long, but Mallory said something very important there that I think that you should always go back and reflect on. And don't try to look smart. Just be very clear in your communication. And honestly, one other anecdote, just to show how true what Mallory said is, we actually had this Bayesian conference at Oxford. It was just it was semi-small conference, but basically it was on Bayesian statistics and big data. And we had all these like grad students coming in and showing like their complex inference algorithms, made it like as hard as possible to understand, so that everyone knew that you're a smart person. Like, good for you, gold star, you're a smart person. No one can follow your presentation. It's so friggin' complicated. Well, for you, good for you. The two key speakers came in. One was E.Y. Tay, who anyone in Bayesian nonparametric, one of the most respected statisticians living. The other is Zubin Ghermani, again, one of the most respected like probabilistic machine learning people. I understood every word that they said. Like literally, it was the clearest presentation ever. They didn't try to be smart. They gave a high level presentation and everyone followed it and understood. I was able to ask a question. And so like, honestly, emulate the best, be a good communicator, put yourself in the audience's shoes. So I think, I don't think that can be underscored enough. Mallory, did that kick off anything? I know I just went off on a rant, but anything to add to that?
Yeah, I think you hit it on the nail on the head. And I know going along when you said like, don't try to sound too smart. I know at the Institute, a lot of times we try to avoid having like a teaching tone when we're presenting something, because it can be like a little condescending and you don't want to kind of dig yourself into a hole sounding too smart. And then they'll ask you a question that you don't know. Like, I always err on the side of being more humble and honest, because you want them to be able to trust you, and you only know what you know. Like, you don't want to sound like you're trying to amp yourself up.
Yeah, and honestly, if you list the things that you don't know, that actually makes a more interesting conversation. So like, it doesn't make you look weak. It just tells you, because when you list something that you don't know, you usually have to put it into plain English. And when you do that, that is a good way to get audiences to click, because it's interesting and it's stated well and simply.
Right.
Cool. All right. Mallory, your next question is, this is also from Resaline. What is the most interesting thing you find about your curriculum in data science in general? So first, what is the most interesting thing you found about your curriculum? And then we'll talk about the most interesting thing about data science in general.
Okay. I feel like I've said this a lot, but the curriculum at the Institute is very focused on yourself as a professional, as well as you growing kind of on the technical side. So I know this past week, we've had a communication week boot camp, or basically 9 to 5 every day. We've been going through how to look into the camera when we're talking, how to reduce filler words. We've been practicing presentations with groups and by ourselves, and trying not to read off a script and all of this stuff. So typically the things that are overlooked in other grad programs, we really focus here. So I've had a lot of practice preparing presentations already, and it's only been a month. So I think it's really interesting to kind of get that super rich professional training along with the more analytical training that I'm getting. because then we just put the two together and it kind of makes you a full, well-rounded data scientist at the end. So it's a really neat process.
Well, that's just because you haven't gotten to the linear programming bit yet, right? And then that'll replace it. But yeah, no, I think that is cool. And so the second bit, what is your most what do you think is most interesting about data science in general?
Yeah, I think one of the parts that kind of drew me to data science initially is that I could work in any field with anybody, doing things that I love. So I know, like, for a practicum project, we have like 20 different topics that it could be about. And I just think it's fascinating that so many different companies need the same thing. And you could literally work in any niche that you really kind of identify with. And I don't know, I just think that is really cool. It kind of like brings together a lot of different industries that are kind of polarized.
Yeah, everything that you've said is correct. My answer, I'll keep it short for this one since I went long with the other ones. Most interesting thing I found about curriculums. Actually, as a rule, I don't enjoy most like academic curriculums. I've always enjoyed research. And so just to not make that sound totally weird. So for example, when you do a master's degree, the applied research project that you did was always the bit that I enjoyed the most. For my doctorate, very fortunately, since I was in the UK for it, the entire degree itself was a research degree, so we didn't have a run up with coursework. And it was the research that I enjoyed the most. Data science in general, my favorite thing about data science in general is essentially probabilistic representations of complex phenomena. There it is in one sentence. That's what I love the most. That's what I spend a lot of time thinking about, even when there's no particular problem at hand. And that's that. Cool. All right, before our next question, just a quick thing. We got 13 people watching, but we only got 8 likes. So let's sure to pop that like button so that more people randomly out there on the internet can see this. And our next question is from, is it Yuja Chen, which says, what kind of skill do we need to know at least for an internship? Mallory, would you like to take that one first?
Sure. Yeah. Cool. I think for an internship, you're definitely going to have some programming experience. If you only know 1 or 2 languages, that's all right. There are so many resources like DataCamp and Julia and LinkedIn Learning where you can buff up those programming skills. But also a little side note about programming, once you learn one language pretty well, a lot of it is just transferable to other languages. You just need to learn the new syntax and nuances. So like the process of learning a programming language, it's going to be the same for anything that you learn. So don't like shy away from learning new things. It should be pretty similar. And also for an internship, it's really important to have a good resume. I know that's kind of common sense, but that's going to be the thing that gets you into the door, that gets you an internship. So having that up-to-date resume with the buzzwords that you need that's tailored to each specific internship you're applying to is going to really stand out. And then, so you just have to have the resume to get through the door. You need to have the great interview skills. So do mock interviews, watch people that you really idolize, watch them and their mannerisms when they're talking and stuff like that. Because the hardest part in undergrad is getting through those barriers and actually getting the job. And then once you have the job, you have the skills that you need to learn everything.
Cool. And so just to underline the highlights of that, one, get your resume checked out. If you're at university, there's a career service who will help you do that. So do not, before you pester anyone else with your resume, pester the university. They have people who are keeping is up to date on the way to get all those buzzwords and fancy things in. They also usually have people dedicated to technical resumes as well. So it's not like you're going to get some person who has no idea what you're talking about, what you're up to. You can get that done so that you can actually get your foot in the door and have an interview. For the interview, obviously people are going to be asking you questions. And while you might think that you're super great at answering questions in your head, the fact is the moment you have to actually put those thoughts into words, it's not going to come out well. You need to practice. Talking to yourself well, most of us probably talk to ourselves anyway, but this time you need to talk to yourself out loud. You can write out the questions that you think they're going to ask, and you just answer them. And it sounds really stupid when you're talking to yourself alone in a room, but you can do that, or get a friend, get a dog, get a parent, get a sibling, someone who actually loves you and is going to let you ramble through those. You might not feel comfortable doing that, but the fact is you do need to practice it somehow. And I think that one quick tip is, some people in your life are genuinely interested in what you're doing. So effectively, you can actually replicate an interview-like scenario by letting them just ask you about like how your day was and what you've been up to and things like that. So I think that's one way where essentially you can have a fundamentally non-fake conversation while still practicing your interview skills. And your first time through is going to be rusty. The second time through is going to be a little bit better. Your third or fourth time through answering these questions is going to be infinitely better than that first time. So practice. Mallory got that one right. What was the other one? Coding skills. Yes. Go to Udemy, go to wherever you need. You have to code because you have to be able to do data analysis. You need to be able to collect your own data. Well, the main skills I would say is, so the original question was, what do you need to know at least for an internship? And I'll say this is one thing you need to know for an internship. It costs people the time to run interns. Like there's no massive net value to having a bunch of interns. It's actually more of like it's more like volunteerism to manage interns than it is like you're getting some massive value out of them, unless you have like super high end interns. But so keep that in mind, because basically what you need to show is that you're basically going to give people a good return on their time. And so in order to do that, if you can code and things like that, you'll need less hand holding. Not to mention, I'm not sure people can function without code to begin with. But yeah, so honestly, just underscoring everything that Mallory just said, I think is correct. The next question is, what steps did you take to prepare? This is Jeremy. What steps did you take to prepare, if any, before starting your MS in Analytics program? So that is not directed at me, Mallory. That is your question.
Awesome. Yeah. So a great first step is the Institute for Advanced Analytics website. That is kind of like the Bible. There is almost anything that you need to know about the Institute is on that website. They have all of the current students and their profiles. They have past employment reports, past alumni, that blog I was talking about. That is your one-stop shop to learn everything about the program. So I would start there, and that's where I learned on the program. I saw the graduation rate and like the base salary and what all the alumni were doing. And I was like, this is amazing. I want to go here. So throughout my undergraduate career, I would go to the interest fair things for the program, and I would ask questions. And I got to know the head of admissions. Her name is Val Schwartz, very nice lady. But I asked her a few questions too about the program, and I was just trying to stay as engaged as I could with the program while I was an undergrad and learning as much as I could. And I think that really stood out when I was doing my interview. Like they could tell I knew what the program was and I was really interested in it, and they enjoyed that. So use your resources that are available to you and learn as much as you can about it. And reach out to me, reach out to any alumni or current students. It's such a great network of people, and we're happy to answer any questions and give any advice that you'd like as well.
Yeah, all that is correct. You definitely not only, so obviously, I think when this question is posted, probably he had technical aspects in mind, but I think that you actually hit on the most important things, which is effectively you need to make sure that the people who will be admitting you, because there's no point in preparing for a program you don't get into. Make sure that the people who are admitting you know you. You've represented yourself well. Just very quickly, did any of your professors who you had at NC State during your bachelor's degree program, was there overlap with your master's degree program? Either they were the same people or at least they collaborated or worked? Nope.
No, there wasn't any overlap. I think they knew of each other and were like familiar, but I didn't have any professors that taught both my undergrad and my master's courses. And also, you kind of touched on it a little bit, but in terms of technical skills, we take people at the program that have never even coded before. So you don't need that baseline technical skills. They kind of really focus it on the person, and they'll teach you everything you need to know. But like for me, being a undergraduate statistics major, they expected me to know some baseline knowledge. So they do appreciate initiative. So if you're a biology major, for example, but you're taking classes on the side to learn programming, they'll really appreciate that. So just show the initiative, show that you're driven to go to the program and learn new things.
Yeah, definitely. A student who has drive is a lot harder to create than a student who has been taught the correct things already. So one thing is essentially your location. That is, what you've learned already. But drive is a trajectory, and essentially, you can do anything with somebody who has a trajectory, as opposed to just being, a point on a plot. So I think all of that is perfectly correct. Yep, sweet. So correct that I'm not even gonna bother adding anymore. Sweet. Okay. Next question, which is from How. I'm really interested in getting a data science PhD, but do you think it is necessary to pursue a PhD in data science? So I'll take this one. Do I think it's necessary to get a PhD in data science? Well, depends on what you want to do. If you just want to get a job in industry, I would say no, you don't need to get a PhD. And in fact, in some cases, it might be faster and easier to get a job in data science, for example, with a master's degree. And that's also just from personal experience, where honestly I've been reflecting on this recently, because I like Mallory suggested, I actually went onto the website. I was looking at some of their acceptance rates and how many people they're through putting things like that, and I was reflecting on my own process of back when I only had a master's degree and I was applying to jobs. And honestly, I think my success rate for job applications to job offers was higher as a master's degree student than it was as someone with a PhD. So I don't take it for granted that you need to sink, another 4 to 6 years into your education just to get the job. If you want to work in academia, you don't even need a PhD, by which I mean you can work in academia, for example, as a research assistant or something like that. There's a lot of jobs at universities who are looking for people with master's degree level research, which is actually the first job that I got out of my master's degree, is working for the Oxford hospital system in a research lab. What you would need a PhD for, if you want to go into the higher levels of academia, you want to become a professor or something like that, pretty much that's just par for the course for what you need. I'll just say this. The main value of getting a PhD is effectively that it teaches you it's supposed to teach you how to be an independent researcher, using, in this case, an analytical, a data science, statistical skill set. And if you don't walk away from a PhD with that skill set, then you failed at your purpose of doing a doctorate. And you can basically do that and leave and be no better as an independent researcher than the day that you started. And that's just a sad fact, but it's true, and people need to say that. So yeah, I would say that's the main thing. Depends on where you want to go, but no, you absolutely do not need a PhD to get a job in data science. In fact, there might be many advantages, and also there might be advantages to working a job as a master's degree level person, which obviously a master's degree isn't a level, it's just like an accreditation. But I would say that there's probably a lot of advantages if you have a master's degree, you're charging in the job market, you get some experience, and then you decide if you want a PhD or not. But yeah, it's a bit of a complex question, but I think that hopefully will answer it for your purposes. But yeah, feel free to pop in a follow-up question in the chat if that doesn't quite answer it. All right, next question is from Benson. What is the typical day like for you? Sorry, Mallory. Did anything I just say, did that help at all, or did that ring true in any way? What do you think about what I just said?
Yeah, I agree very much with everything that you just said. And I'll reiterate it a little bit. But I think if you want to go get a job in data science, you don't necessarily need a PhD. I think if you really enjoy research, getting a PhD can't hurt. But I know in my case, like I just wanted to go into industry. So I just wanted to get what I needed to get there. So kind of talking to people that maybe talk to someone who has a PhD, talk to someone who got their master's and see the kind of things that they're doing. And if you like what they're doing, kind of follow their footsteps. So I would say only do what you need to get the job you want.
Yeah, that's pretty good. Actually, what you said, it reminded me of something else. Unfortunately, just fell straight out of my head. Oh yeah, actually, yeah, here it is. If your goal is to get a job, it's more important that you choose a program that will help you get a job afterwards. And this is a big thing. It's one of the reasons why I was complimentary of the NC State program and didn't just start rattling off of other programs. It's one of the reasons why I asked Mallory to come on, as opposed to just asking a random grad student at some other place that doesn't focus on this. Because fact is, the program that Mallory's in takes a very big focus in making sure you get a job afterwards, as in they have a large number of industry connections. That's part of their selling point. And so I know it sounds a little bit mercenary at the time, but the fact is, that's what you want in a program. And in fact, that's what you deserve out of a program. You deserve a program that proactively helps you get a job afterwards to pay off the tuition that you paid them. It's like, that's the trade-off. And a lot of these programs will be like, oh, data scientists earn X amount of dollars afterwards, and they'll pop up some nice, good solid 6-figure salary about what you can expect. And therefore it's like, well, therefore our program warrants this type of charge because you can expect this afterwards. And it's like, nope, not even true, because the fact is there's survivorship bias in every salary account. And you can read Taleb on these things, but it's like, that's amongst the people who have data science jobs. If you don't get a data science job, your salary from data science is $0. And so I think that's something really important to keep in mind, because like there's a lot of like zero censored data scientists, as in people who went and got the degree, and if they can't get a job afterwards, it does no good. And that stat where it's like, oh, they need like X 100,000, a trillion billion missing data scientist jobs each year, they'll be sure to hire you. It's like, no, that's not true. One of the reasons why there's so many missing or unfilled jobs is because people don't feel like that the applicants have the skill set to actually hold down that job and warrant the salary. So I would just reiterate that you should definitely, if you're interested in getting a job, look for programs that actually provide statistics on how well their students do. I mean, you'd expect that anyway. They're giving you a master's degree in data science. Presumably they're at least going to create a little dashboard about who's doing what afterwards. That's basic data. They should be using data at least as well as they teach their grads too. I know that's a bit of a rant, but since there are people out here who are probably in undergrads and they're trying to select between multiple universities, and you'll probably have multiple offers, look for the ones that have concrete information about how they help their students, not just passively. There's a lot of universities who will passively help you, as in they give you the degree, but that's not helping you the way that you need. And once you hit the job market and you get your first like 5, like you'll apply to 10 jobs, 5 will like not even reply to you. Another 3 will take the time to reject you via email. And then there's the next 2. One of them is being a headhunter, is going to treat you like trash. And then there's like 1 who like you'll get an interview with, and they'll still probably reject you after the first thing. Like, get ready to have an iron stomach with regard to these types of things, because it will be tough. And I think a university who's on your side will help smooth that out, if anything, because they'll treat you nicely, because they have to go back to the university that they're using as a feeder. So crud, sorry, I ended up going long and stealing that question, but Mallory, is that right? Does that sound right at all?
Yes. Yeah, that was like the main selling point for me applying to the institute too, like seeing the percentage of students who had a job outside of graduation. Like that was exactly why I wanted to get my master's. So that's why I wanted to go, So I 100% agree with everything you just said.
Yeah. And again, it's just like, don't let the sort of broad statistics about like how many data scientists are needed in the workforce and what they earn, don't let those fool you. There's a process behind those numbers, and that might not play to your advantage. Getting a master's degree in data science or a PhD in data science, is not the magic cure to playing well with those numbers. There's other things afoot that you need to keep in mind. Cool. So next question, Benson's, is what is the typical day like for you, comma, Mallory? What is the main difference between a data science and a data analyst? Is it possible to switch between these two jobs? So actually, maybe just do you want to do what is your typical day like? And also, if you could give us your typical week, that'd be good too.
Yeah. So we have been virtual for this whole summer, but a typical day is going to be similar once we're in person. But what we've done is in the morning, we either have programming or analytics class, and then whatever we don't have, we'll have in the afternoon. So let's say Monday, I had programming in the morning, analytics in the afternoon. We would have videos to watch on our own before each lecture. And then when it was time for lecture, we would be put into groups and we do labs together. So we would learn it on our own, come ask questions together as the big group, and then we would go out into our own individual groups and do some labs together. So it was very collaborative. You'd learn on your own, then you would get your questions answered, and then you would reiterate what you've learned in groups. So we would kind of do that every day for the entire week. And we also had some projects that were kind of like over all of our class that we needed to be doing. So we had a summer practicum project. So we'd probably meet for an hour or two each day with that group after we were done with our class and just kind of work on that project.
Cool. Yeah, no, I like that. I also very much appreciate there's something called the tutorial system. Where effectively you're expected to sort of you learn in advance, you see your lectures in advance, and then you have this more engaged process afterwards by which you learn. And I think that's a very productive way of learning. Other than that, yeah, I think that's good. Do you want me to take on the difference between a data scientist and a data analyst? Okay. Cool. Yeah. So one, these terms are fungible, and effectively they are whatever the person who's paying you a check says they are, because they're the one writing the rules. However, there is a general trend difference, whereas a data analyst, typically a lot of their work is more like the ETL style work, which essentially data like extraction, transformation. They will do essentially like visual analytics and things like that. So effectively, you might need you might be doing a lot of like SQL activity and straight up analysis. But essentially, maybe a good differentiation is how much data modeling you might be doing. So whereas a data analyst might be just looking at the data, taking the data, looking at different views of it, conditioning it essentially from a visual and a non-formalized process, so non-formalized data analysis. Whereas the data scientist might have to formalize the data that they're seeing, for example, into models. I don't want to sell any data analyst short. It's actually a good data analyst. A good data analyst produces as much value as a good data scientist, I'd say. I believe that data scientists tend to get paid more, but there's a slightly different skill set. There, you are expected to have like data modeling and things like that as part of your skill set for that. But I don't think that, especially at the entry level, a good data analyst, well, at the top level, a good data analysts are very productive people. And I'm just also saying that because as a data scientist, I wanted to be very clear that most of us categorize ourselves as either statisticians, data scientists, machine learning scientists. But data analysts form an essential function for a lot of companies that should not be underappreciated. But yeah, I hope that answers your question for that. And just so you know, we are getting to the end of our pre-submitted questions. So if you have any follow-up questions, it takes us about 30 seconds to see them. So please start submitting those now so that we can answer them before the Q&A ends. And our final question is, this is a good one from Nashua. What kinds of projects do you do in and out of work? How do you find an idea and resources for the projects outside of work? Cool. Maybe should I tee this one off, and then Mallory, you can follow up?
Sounds good.
All right, sweet. Projects inside and outside of work. So just for some quick context, my data science role is within a software company. So effectively, the biggest sort of blind spot from my own capacities comes from the fact that I don't appreciate software engineering as much as essentially the most value delivering colleagues at my company. So one of the places actually, when talking about side projects, they aren't data science side projects. They're actually learning more about software engineering. And I found that very useful. And I think that these are the types of things, especially as I think that there's probably going to be a new role. I can't tell you what it's going to be called, but essentially it's going to be like a data savvy software engineer. And those people are popping up. They're even popping up at my own company where a lot of people, you don't want a full blown data scientist, being bogged down into their sort of like empirical mire that they usually get with these tasks that have like this huge mission creep. But you might want a software engineer who has an immense skill set to be a little bit more data savvy, so they can sort of do some things themselves. They don't need to go to a data scientist. They can sort of hypothesize about data and sort of conceptualize it differently. And so what I'm trying to do is be a bit more of sort of the flip side of that, the mirror of essentially a software savvy or software cognizant data scientist. That's one thing that I do. Another thing I do is I do actually just sort of fiddle around and look at things, and I'm actually going to be popping up one of those little projects on the channel at some point in time where it's just like a really good time series modeling exercise that I find interesting. Resources, ideas. There are a lot of open source data sets that are out there, not to plug the channel, but my goal is to create about, I'm probably going to do a week where I'll release a video per day on open source software, and I'll give you a tutorial about how you can use it and things like that. One of them is definitely going to be for CGM. Most likely one of them is going to be for hospital patients. One of them is definitely going to be an environmental one. So there are a huge number of open data sets out there. But honestly, if you are looking for data, just Google open data set and then type in whatever topic you want, and you'll generally be able to find something. But I hope you find that useful. And I'll dig into that one more, but it's a separate topic. Find ideas. Honestly, it gets back to what Mallory said. My ideas are inspired by what I'm working on right now. So it's not like I'm trying to go out and find these far-fetched things. It's how do I solve the problems at hand? What are the bits that I can't directly answer as far as my current project, just because the scope doesn't really allow for that, but I'm still curious about. That's the type of thing that I work on outside of work. And I do work on things outside of work. Obviously the podcast is something else I do outside of work. But yeah, that's about it. Mallory, I'll repeat the question to you and you can figure out what you want to answer for it. What kinds of projects do you do in and out of work, and how do you find the ideas and the resources for those projects?
Okay. I guess I'll talk about mine outside of work, because the ones we're given at the Institute are kind of like, they give us the data and they give us the problem. So that's more like not my own work. I mean, it is my own work, but I'm not coming up with it. But I did a few side projects with my gym job I was talking about. We had data about when customers were coming to the gym and our most popular types of memberships. And since I worked there every day, it wasn't a technically like analytical job, but I thought it was so cool to be able to pull that data and show some visualizations to my team to kind of show them, like, say, hey, look at all these people that are coming at noon. We need to be on our best game at noon. So just there's data all around you if you look for it. So if you're inside, if you have a job, if you're kind of super deep into a project or anything like that, try to see if you can find some data and help your team, because even like working at the gym, I still find a way to incorporate data science and visualization into there. And side projects, if you are passionate about it, are such a great thing to be able to talk about. You have a talking point in interviews with other professionals when you're networking, and you get that hands-on experience of learning something on your own. So if you are super interested in something, find a clean data set and see what you can find from it. I think it's such a great opportunity that a lot of employers and schools are going to be looking for. So, and like Glenn said, it's pretty easy to find the data online if you just Google it. I know Kaggle is also a great resource for data too, if you're looking there. They have a lot of data sets you can download.
Yeah, that is it is a really good source, even though no one will ever agree on how to actually pronounce that word. But yeah, it actually reminded me of something else because you're saying, you can find clean data sets and you're talking about the data sets that you found at work. One thing I'd strongly recommend people do, because when you are early career, your time is extremely valuable. Like it's actually a weird thing where your time isn't of particular value to other people because you're new, and so they'll use it up and they won't pay you very well for that time particularly. But at the same time, it's extremely valuable to you because there's so much that you can do with that, where it's like how you spend your early career well. If you spend it well, it will massively set you up for success later. It's like interest, and how you invest early will collect more interest than how you invest late. And so one thing, if you are going to say, I'm going to dedicate myself to doing outside projects, or this might even help you decide, like within your own job, how do you select a project? You want one with like a long runway, as in it's not just going to be a one-off project that you hand in your report and you walk away and it's all dead. And one of the things that I've hit on previously is like, how do you identify a project with a long runway? And so, for example, maybe take Mallory's gym example. Like, when are people showing up and things like that? Like, was that derived from an electronic record, or are you looking at, yes, so it wasn't like you were looking at people's paper gym sign-in things. It was an electronic record, which shows that the cost of acquiring more data is inexpensive for that, right? Like, that data set has grown since Mallory last looked at it, right?
Mhm.
Yeah. So there's something where it's like, compare that to, for example, if there's a paper record. Every time you wanted to have that paper record to update the data, to make use of that data, to re-deliver it back to people, you essentially have like a transcription process. You have to there's a huge burden to it. And so if you can look at things, for example, where's data collected electronically, that's a good example of where there's a low cost to continuing that data set. If the data set continues, then the need for analysis continues. Also, it'll be easier to analyze because it's already in electronic format and things like that. So I think what you've described is something where these are projects that have a long runway. And getting back to the idea about when you're young, you need to be very judicious about the projects that you're spending your time on. One sort of, you can take the approach like say yes to everything, and say yes to everything until you have something really good. But once you've hit that thing that's really good, make sure that one, you've correctly identified that it's good, and two, stay on it, really pursue it, like really plummet for the depths of what it has to offer. Again, then execute the depth first search of your skill. So do breadth first until you find something good, and then the moment you find something good that people care about long term, really just go after that one and get really good at that. And I think that will give you sort of that confidence in the experience. Because maybe one final thought is, you can actually have more experience than people who have been in the field longer than you if you have more depth. So, and one easy way to get depth is if you have someone who's had the same 1 year project, so they've done 10 1-year projects, they're not going to have the depth of someone who's had 1 2-year project. And so there's an 8-year advantage that you can claim back. And so I think that's something important. Mallory, does that any of that catch your fancy or anything like that?
Yeah, no, I agree. I think it's really important to be able to like continue and really get deep into the project that you're doing, because there's only so much that you can do at the surface. Like a lot of that learning and growing comes from going deeper than you can in probably a year. So
Yeah. And also, yeah, if you ever wonder why, your professors and people, they seem like they really know everything, it's generally because they learned one thing deeply. And those deep connections then just make it super easy to make the connections on all these other broader concepts. So I wouldn't suggest that you try to take the approach where I'm going to try to learn everything broadly and understand it. I don't think that's the way to do it. I might be wrong, but I think that's not the way to do it.
I agree.
Cool. Well, since we're wrapping up, what I'm going to do is I'm going to quickly read through the final comments. I believe we have some questions in here. You're going to have to forgive me for squinting as I look at a screen. It's about like 5 feet away from my face. Okay, cool. So if you're going to any grad school, their program should tell you their placement rate. I'm a BI developer and had my headache with applying after graduating. Yeah, that's definitely true. Looking at their placement rate is something that's important. making sure that the company or the department actually has a plan to place people is even better. There's some amount of you're due for a headache either way. So like you aren't alone in that, but some companies will reduce it substantially. Some departments will reduce that substantially and really help you out. So I think that Resaline, you're not alone in that, but yeah, you are correct that you should be doing your homework on that. Mallory, if you want to comment on that while I find the next question.
Yeah, I think it's definitely important to try to look at that because that's your main outcome from grad school. So it can be a headache, yeah, when they don't say it right ahead, but email the faculty, kind of pester them to get that information because you need to know that when you're applying.
And also look at the reply rate. So it isn't just how many people they've placed, but it's how many people are responding. Because the fact is the people who don't get jobs are probably not going to be too keen to reply to the people they just paid a bunch of money to, that they didn't get a job. So I think that's another important thing. I think actually like a lot of law schools had that issue where they were quoting these really high salaries, but what they were ignoring was essentially the 0-centered people who did not get a job within their field. So there is something. Okay, the next one is thanks Mallory and Glenn for having this Q&A. Well, thank you, Mallory. I really appreciate it.
Thank you for having me.
Okay, thanks so much for the Q&A. There's no one. Okay, here's our question. What would you do to get past an obstacle, idea-wise, during a project? I'm currently working on a volleyball analysis project just for my own interest, and I also get stuck on what to do next. And this is posted by a rising second-year undergrad student. I'll kick this one off since I tend to have been dominating this conversation. Unfortunately, I should definitely be letting Mallory speak more in the future. This is actually gets back to the question about, for example, the value of a PhD. And when we talk about independent research, getting good at independent research, one, it isn't something that you're born with. You're always going to be sort of in NPC mode, non-player character mode when you start. That was me, and when I started, and now I don't lack for ideas. Like I've literally never, since 2015, since about the beginning of 2015 and to 2014, I've never lacked for ideas about where to go next in research. However, prior to that, I did lack for ideas, and it's one of those things where you have to get experience with it to keep going ahead. And so you should not, so the first thing that I want to tell you is that just because you're lacking for ideas right now does not mean that that's like an inherent state that you'll suffer through for the duration of your career. You will get better at this. You just basically need to you need to get practice breaking out of those, those shells. The next bit is, one, you are doing something very smart working early on a project. So I would just congratulate you for that as well. You're definitely doing the right thing working on a real project. How to get stuck? Honestly, I'd talk to somebody. You need to talk to somebody who's going to listen to your work for long enough to appreciate some aspect of your project, and then they can help you out. One thing that I want to do with the podcast is start having conversations with early career people who are stuck or want some ideas on the problem that they're working on, and essentially talking to them through it, because that's one of the things I love most about my time in a doctorate and afterwards is helping other people break out of the ruts that they have. But there's nothing wrong with you for being stuck in a rut. I would say this, just to try to rattle off some quick ideas. How are you looking at your data? Are you looking at it, for example, in a univariate way versus multivariate way? Start conditioning your data and looking how the data varies under different conditions. That will start sparking some intuition onto the correlation or the relationships between these different variables that you might have. And that will spur new questions and things like that. Secondly, if you're using models, look at what the parameterization of the models are. Are they a complex model? How's the model being fit? Are there ways that, for example, you can be changing the inference style that you use, and what differences does that produce? Things like that. Cross-validate your model. So you'll start seeing odd things there where just like if the model's bound to explode at some sort of cross-validation cut, like it'll eventually explode. It's gotta, so there's gotta be something there. And like, if you look at why it did that, look at the nature of the data. Start flagging outliers. things like that. So essentially plot, I'm not talking about models here, really, just like take an IID distribution of each univary, each marginal distribution that you have for each feature, and sort of plot the probability density of the data points with respect to that model. Change what the distribution your family you're using is, like a normal versus a gamma, things like that, where essentially you start just sort of like you're like sort of shaking the sand a little bit and seeing sort of what comes out of it. Things like that, you'll start noticing oddities of the data. And finally, I would say if nothing works out, one, like just ping me a message and we'll record something, we'll talk about it. But if nothing works out, consider that this project might not be one with a lot of runway and switch projects. So there's the other bit. Like one of the best skills you can have is know when to essentially abandon a project. Yeah. I was gonna make a Titanic reference, then decided that probably wouldn't be in bad taste. But yeah, know when to abandon ship. But Mallory, what's your call?
Yeah. I just had a few quick thoughts. You could always, I'm not sure if you found this data on your own or if someone gave it to you, but going back to where you got the data, and if someone gave it to you, asking them questions like, hey, like, what else do you want out of this data? Because a lot of times they'll put it in really simple terms, and then a lot of your growth will come from you trying to actually implement that. They're like, oh, I want to see if there's a relationship between these players and if they perform better in fall or spring or something. Like that's super high level overview, and that's where you can do a lot of the growth and actually learn that question. So don't be afraid to ask the people that gave you the data for more clarification. Don't be afraid to ask your professors for help, and new ideas that you can maybe try. And if it's possible too, you could try to find more data. Like if you have some kind of identification on the players, like their name, you might be able to find like another variable that you don't have that might spark some new information as well. So maybe searching for more data as well could spark some new ideas there.
Yeah, I should have let you answer that one first because I think you actually did the more fundamental bits that are, yeah, you're correct. That if given a choice, listen to Mallory's answer first. Definitely. Several things are, for example, when they bring up these things, you might actually find out that there are probably answers in the data that you don't appreciate how valuable they are for the actual data owner. So they might bring these things up, and actually, it reminds me of a conversation I recently had. Where effectively I was working on something more complex and found out that they would have settled for something way simpler that I could have gotten them faster. And that was exciting and fun. As Mallory mentioned, also expanding the data set. So that isn't just adding features, a new table to join to that, which could be cool. For example, say, how do I want to go? I have two things I want to do. Okay, yep, I'll do this one first. Expanding the feature set. So say, for example, you have players now. Now you have personalized performances. So effectively, anytime you have like these broad statistics over the entire data set, is there a subset of that, whether it's a person or a group of people, for example, individualized? It can be the ball specific statistics, it doesn't matter what it is, but essentially you cut it down to a specific subset of one dimension and essentially do precision analytics on that dimension for different values and see if that varies. And that can be extremely helpful. Like a lot of people hear about precision medicine. My approach to that generally is, you take one dimension that's particularly important, like the individual patient. You cut it down to that one dimension and then look at subsets of that. In that case, the individual patient or subgroup analysis and things like that. So that's very helpful. One other thing that you can do, drawn entirely from Mallory's much better answer than mine, is that you can expand the data set in actual size or add an additional data set. So you might have your volleyball data for one team or a certain number of games, add a new season, add a different team, be a mercenary and go to their enemy and get those people's data too. You can do all these things where you just expand it. And that might bring up, you can actually see, well, what is the model from one data set versus the model from this next one? Does the precision analytics change? Things like that. Is there a time series component to this? There's always time. Time is one of the dimensions through which we flow. There's usually a time series component to these things that you can do. So yeah, I think, Mallory, what did I miss on that one? Show me up one last time before we go. What other ideas you have?
I think you hit the nail on the head with that one. as our professors always say, the more data you have, the more problems you have, which in this case, it's good to have these problems so you can get over those obstacles. So any data that you can get that's somewhat related to it will spark that new inspiration. So
Sweet. Yep. And with that, we have a few final thank yous. Thanks for the great information. Hope it's helpful. We'd like to do more of these across a variety of people. Mallory, last time we talked, Mallory will be showing up again as long as she is willing to. I'm very eager to track her learning process through her program, because I think that it's like a fundamental growth stage. It's a very exciting thing. And for like old people like me, it's always really exciting to see people like taking off in the field and seeing what they're going to do, especially when they're pleasant to deal with. So
thanks.
I'm really interested in essentially, because one thing that we don't appreciate is, it's not just about what you learned, but it's how you learned it, the framing, how you conceptualize the things that you learn. Because, you can, I was about to say you can teach people things, but I'm not sure you can like teach people things so much as like you can set them up to learn, and how they sort of frame and conceptualize that learning on their own it's very interesting. So I'm very interested to see those for the different topics. And so that's something that, because for example, I believe you do have an optimization section of your curriculum and things like that. And so that, for example, optimization is something that a lot of traditional statistical programs don't cover as well as they could, even though essentially optimization is part and parcel with statistical inference. Unless you're an integrate, but whatever. But you get the idea. And so I'm very interested in essentially segmenting some of these things and chronicling Mallory's learning journey. So to whatever extent she's willing to put up with my questions on that, I look forward to that. But yep. And then the final question is, we actually got quite a few. A big fan from the UK here. I appreciate that as someone who's lived in the UK for actually probably the majority of my adult life I spent in the UK. Funny enough, I was thinking about this today. I lived in the UK I've spent probably 8 years cumulatively in the UK. I haven't driven for a single minute of that time. I thought that was funny.
Yeah.
Yeah. Really inspiring. Thank you so much. So again, thank you, Mallory.
Of course. Yeah. Thank you.
Cool. And one final thank you for such a great session. So with that, Mallory, what are your final words of advice to everyone? And I'll give you, just take as long as you need.
All right. I know that the field can be kind of daunting, and like looking at people that have gone to so much school and are doing great things, like it can be overwhelming and scary, and you can feel like you don't know a lot. But something I firmly believe in is you can learn anything if you put your mind to it. The things that are really important are who you are as a person. Like there's only so much that you can change about your personality. Like you can learn how to have all the soft skills and all of that stuff, and you will learn the things you need when it's time to learn. So just try not to get too overwhelmed or stressed out. Just learn as much as you can, enjoy learning the things that you're learning, and try to grow as a person as well. Don't focus only so much on the actual academic part of things, because there's so much more to being a professional than that. But you've got this. You will be fine. And thank you so much for listening to us talk today. It was really fun to be here.
Perfect. I have nothing else to add. Mallory, thanks so much for your time, and I'm looking forward to our next conversation.
Me too.